We have done pretty much everything that we can do with energy for now. We are going to look at power. Power isn't about the energy itself, but about the rate of transfer of this energy. So it is an energy rate. And I will first give you a simple formula. Power is work over time. Work is a change in energy. So this has units of joules. Time is, of course, in seconds, so the units of power come out to joules per second. And 1 joule per second is how we are going to define a watt. This is a watt. Just gets a capital W. So then we've got power as work over time. When we do work we know is a parallel force times a distance. So then power is a parallel force times a distance divided by a time. Sometimes the kinds of problems that we come across are as simple as we have this force that's being applied for this amount of distance. It's happening for 3 seconds, so can you find the power delivered, the average power delivered? And it's just the total work divided by 3 seconds. Sometimes we have to be a little bit clever about this. A distance over a time, well, that sounds a whole lot like a speed. So a different way of expressing power is to say that it is a parallel force times the speed. Once upon a time, I did talk about average versus instantaneous, and this is a spot where that comes in. If I have a graph like this of the energy in joules versus the time in seconds, and maybe my graph looks something like this. And we'll throw some times on here. We'll call this one 10 seconds. If I want to find what my power is, the power delivered at a certain time, like at 10 seconds, what I'm looking at there is an instantaneous power. Now power is going to be the slope in general of the energy versus time graph. Right here, this slope is pretty flat. Right at the top, it's kind of a turnaround point. So right here, I would expect that the power is going to be 0. But if I wanted the average power over those first, let's say over the first 50 seconds, I'm going to say I know my energy here, I know my energy here, I'm going to connect those with a straight line, and my average power delivered over the first 50 seconds is just the slope of this line. So if I know some of these values, maybe this value up here is 100 joules. So we can go 50 here. Then I would say that my average power from time equals 0 up through 50 seconds is going to be 100 joules minus 0 divided by 50 seconds minus 0 is 2 watts. If I looked at my average power over a different time interval, if I looked at my average time power, for example, between 20 and 50 seconds, I get a less steep slope. That's going to be less power delivered. If I looked over the first 10 seconds, I get a very steep slope. That's going to be a much higher power delivered. But that's the idea of kind of how I go about figuring out the power delivered given a graph. And then up here, this was figuring out the power delivered given either an energy change and a time interval, or just the power delivered right in the moment is going to be a force times a speed. That's it. That's really all I can do with power.